HTTP is dead. Is it now? With the rise of AI protocols nowadays, how agents are communicating with the web services, there is a question that are HTTP and APIs are relevant in this era of AI? The answer still is yes. Think like AI protocols are the letter agreement between the two parties, and HTTP is the truck that deliver these agreement between these two parties. You must have already heard MCP, A2A. These two are only few of among them. So if you are wondering what these AI protocols do, how they work, when to use this, you are not alone in this. Agents are being used in every sector, whether it's medical, coding, science, or e-commerce. But here's the thing, we cannot use a single agent for every scenario. Sometimes we need a single agent to perform better in a single task, and sometimes we have to collaborate with other agents and services so we can give a better solution. So I have compiled a list of AI protocols that we mostly use in AI agent nowadays, and we will see how these protocols works and when to use it. Let's start. So our first protocol is Model Context Protocol, and it was developed by the Anthropic. Now while we are making a single agent, the biggest hurdle is that we have to connect our agent with our own databases or an email service or any custom API integration that we use regularly. Now for a single server that works, but what if we want to connect different services, that is 10 to 20 servers, and writing those API integration is a hectic job, and that's where MCP comes in. So Model Context Protocol solve this problem by connecting our application with the multiple servers with a single interface. Suppose we are using one MCP server for connecting database, one MCP server for deploying our application, and another server to send an email to anyone. So this time all MCP server contains their own code, and our application does not need to know anything about how these MCP servers are working. So all codes are independent. Now suppose user want to send an email, then MCP client will see that among these three, MCP server C can send a email to anyone, and it will send an email to this MCP server. Then it's the responsibility of this MCP server to send an email. How does it send actually? Our application does not need to know. And if anything changes on these MCP server, nothing changes on our application. So our app should only know that what features are providing instead of how they are providing. It acts as a plug and play feature. You can add or remove any feature from your agent at any time. If you want to learn and practice to make a model context protocol, you can visit this site modelcontextprotocol.io, and here you can implement your own MCP and create apps in your own favorite programming languages. So our next protocol is Agent2Agent, that is A2A, and it was developed by Google. So we saw in the MCP that if we need any feature, we implement in our own AI agent. But sometimes we cannot implement all the feature in the AI agent, which is a big task. Sometimes it is better to use any third-party agent which is better at their job, and these agents are hosted by some kind of service provider, so we can connect them remotely and perform a task. Suppose I have a KYC agent, that is know your customer, and which is better at its job. So now banks don't have to make their own KYC agent. Instead, they can utilize my KYC agent and connect with it remotely and securely. When user want to perform some action, it send a query to the client agent, that is our agent. But our agent does not have all the features, so it will look for a remote agent. So there is a file well known /agentcard.json file hosted on this remote agent 1 server. This file contains the information about the capabilities of this remote agent 1. So it says I can perform a KYC task. In the same way, this remote agent 2 contains a file agentcard.json, which tells that this agent can do any kind of payment, either with cryptocurrency, credit cards, or UPI payment. So our agent will interact with both these agents, and after these remote agents perform their task, they will return the output, and our client agent will process that output and return back to the user. So this is almost like MCP. In MCP we were connecting to a single database. Here we are connecting to a whole agent, that is an agent which has its own mind, that is LLM, and also it has its own set of tools to perform a specific task. If you want to know about Agent2Agent Protocol, you can visit this A2A protocol.org site and you can learn more about codes and how to implement A2A in your agents. So our next protocol is Universal Commerce Protocol. This is specially designed for e-commerce sector. Now suppose you want to integrate multiple stores in your agent. One store is for buying shoes and one store for buying t-shirts. Now integrating these stores into your application is a task because each store may have different process to do things, how to do checkout, how to apply a discount, how to do a payment. And here's how UCP solves the agentic commerce. Suppose we want to connect our agent directly to some merchant agent which sells t-shirts. So the merchant server creates another JSON file which is well known /ucp.json, and it tells our agent that this merchant supports identity linking, checkout, order and payment mode too. And these UCP JSON also contain information about API endpoints. Suppose if we want to place an order, we can hit this API with these parameters. So we are not implementing any of those APIs in our integrations. Everything is implemented on the merchant side, and merchant server is telling that we can perform these three operations, so you can send requests regarding these. Now if user want to buy some t-shirt, our agent know that this backend has capability of checkout and placing an order. So agent will communicate and perform those tasks without knowing how things are actually happening at the backend of the merchant. So if you want to learn more about UCP, you can go to ucp.dev, and here you can learn more about how to send requests, what features can be performed by the UCP. Now AP2, that is Agent Payment Protocol, is an addition to this UCP layer. So AP2 provides a security and trust for various kinds of payments like stable coins and cryptocurrencies while UCP is happening with the merchant ecosystem and the agentic process. AP2 also creates an audit trail for this whole transaction, whether the human was involved, how much cards was added, what was the intent of the buying, whether the payment was done or not, whether it was done with credit card, UPI or cryptocurrency, whether the payment was fraudulent or not. So these kind of information are being tracked and maintained by the AP2 protocol. I have read that Visa cards are also implementing AP2 protocol, so any agent can use the Visa cards tab features to do payments with the help of credit cards and debit cards. And if you want to learn more about Agent Payment Protocol, you can go to ap2-protocol.org and you can learn how AP2 and UCP are connected and how you can implement in your own agent. In the current AI system, there is a lot of human involvement than you think. In AI, we call it human in the loop, where agent needs human approval or human input to proceed to the next step. So if you are making a mobile or web application with the help of A2UI, LLM can generate a UI on the front end to get some user input from the human. For this, LLM generates a JSON that converted into a UI component directly and dynamically on the front end. This UI component can be a simple user input or an agree or disagree for the terms and conditions pop-up or a checkbox. Every UI can be made dynamically with the help of JSON generated by the LLM. If you want to learn and implement A2UI on your front end, you can go to a2ui.org, and here you can see libraries regarding React, Angular, Flutter, and implement this protocol in your application. Suppose a agentic process is going on and in the middle of the operation you want to call a tool, or you want to open a pop-up for the user input, or simply you want to update the UI to keep informing the user what's happening in the agentic process. So here comes Agent User Interaction AGUI protocol. That means if agentic process is going on, it creates a stream of events like agent process starts, it's ongoing, it requests a tool call, and the agent process end. Convert all these events into some kind of logical or UI process. So in the code we can see that the events are being emitted, like the process has been started, the text has been emitted, the content has been delivered, and the process has ended. So on all these events we can run our own logic. It can be a logical operation, or we can simply update on the UI interface for the user to keep updating what's happening in the agentic process. So here you don't have to make API call to get the current status of the agent. Simply events will be converted into a JSON, and with the help of these JSON on this AGUI protocol, you can update your UI on the front end. You can visit ag-ui.com to learn more about AGUI and how to implement on your front-end application. So we saw that each protocol has their own usage, but they have some kind of similarities, and that's what makes them better and usable in the AI agents. So first is interoperability. That means if we want to perform some tasks, we don't have to create custom APIs and integration to connect with different database, different merchants and different payment providers. We can simply choose existing integration provided by these service providers and connect via these protocols MCP, UCP or A2A. That means if you want to perform some database query, simply connect an existing MCP to your agent. If you want to connect a remote agent, simply connect an A2A into your agent and it's ready to use. Zero trust guardrails. We have come far from building a chatbot to an agentic process doing a payment for us, and it has to be secure. And also LLMs are non-deterministic, and hence these protocols perform a predefined boundaries for the LLMs to perform a simple task. They cannot do high-stake action without the consent of a human in the loop. LLM agnostics, that means they are decoupled from the underlying intelligence. That means let's say with the help of UCP protocols, an agent which uses OpenAI model can use to do a transaction on the merchant which uses a Gemini model. Or you can use a A2A protocol to connect a powerful cloud-based agentic process directly to a local on-device AI running on your mobile phone. Now if I summarize all AI protocols in a single example, think like that: MCP extracts a raw data from a secure database, then uses A2A to send those information to a specialized agent remotely. And for this you need a UCP protocol to make the transaction for the buying process. And AP2 makes sure that this transaction is being secured, while AGUI is keep updating the UI for the user to see what's going on in the agentic process. And after payment is done, A2I makes sure to render all this complex workflow into a beautiful UI native component on your front end. If you found this video helpful, drop a comment and suggest what new video should I make. See you in the next video. Till then, keep learning. Bye.